Welcome to Daily Papers, the podcast where we break down the latest and greatest in academic research. So, have you ever been playing around with an AI like ChatGPT and asked it a tricky question?
All the time. And what's really impressive is when you ask it to explain its reasoning. It will often lay out this beautiful, logical, step-by-step process that looks exactly like how a person would think through a problem.
Exactly. It makes you think, wow, this thing is actually reasoning, it's thinking. But what if it's not? What if it's all just a very convincing illusion?
That is the provocative question at the heart of a paper from researchers at Arizona State University, titled, "Is Chain of Thought Reasoning of LLMs a Mirage? A Data Distribution Lens?"
Let's start with that term, chain of thought. It sounds technical, but the idea is simple. It's a technique where you prompt a large language model, or LLM, by saying something like, let's think step by step. This encourages the AI to break down its process before giving a final answer, just like when your math teacher told you to show your work.
And it works incredibly well. It dramatically improves the performance of these models on tasks like math problems and logical puzzles. This has led many to believe that LLMs are capable of deliberate, human-like reasoning. But the authors of this paper noticed some cracks in the facade.
They give a fantastic example in the paper. They asked a modern LLM a simple question. The day the US was established is in a leap year or a normal year?
Okay, so the US was established in 1776. I know that's divisible by 4, so it should be a leap year.
Right. And here's what the AI said. First, it laid out the reasoning steps. The United States was established in 1776. 1776 is divisible by 4, but it's not a century year, so it's a leap year. So far, so good. It's perfect reasoning.
And the conclusion?
Its final answer was, therefore, the day the US was established was in a normal year.
Wait, what? It correctly reasoned that 1776 was a leap year, and then immediately concluded the opposite. That doesn't make any sense.
Exactly. It's like the model can recite the rules perfectly, but has no idea what they actually mean or how they connect to the final answer. This is the central idea of the paper. The authors argue that what we call reasoning in AI might just be incredibly sophisticated pattern matching.
They call their perspective the data distribution lens. This just means that an AI's ability to solve a problem is fundamentally tied to the data it was trained on. If you give it a problem that looks very similar to its training data, what they call in distribution, it does great.
But if you give it a problem that's even slightly different from what it's ever seen before, an out-of-distribution problem, the reasoning starts to fall apart. The authors hypothesize that chain of thought reasoning is a brittle mirage that vanishes when you push the AI outside its comfort zone.
So how do you test that? You can't just use a huge model like GPT-4 because nobody outside the company knows exactly what's in its training data. It's a black box.
So the researchers built their own controlled environment, which they call data alchemy. Think of it like a sterile laboratory or a sandbox. Instead of training an AI on the entire internet, they trained smaller models from scratch on very simple, custom-made tasks.
What kind of tasks?
Really simple stuff, like giving the AI a word, say apple, and asking it to perform a transformation. For example, a rote 13 cipher, which shifts every letter 13 places forward. So A becomes N, P becomes C, and so on. They could also have it do multiple steps, like shift the letters, then reverse the word.
Okay, so by creating their own data, they have complete control. They know exactly what the model has seen and what it hasn't.
Precisely. And then they tested the AI by making small changes along 3 key dimensions: task, length, and format.
Let's break this down. What does a task change mean?
That's when you change the problem itself. For instance, what if the model learned to do transformation A and then transformation B, but you ask it to do B then A? Or you test it on letters of the alphabet it was never trained on? Or you introduce a brand new transformation C.
Okay, and length?
That's about the length of the problem. If the model was only ever trained on problems that took 2 steps of reasoning, what happens when you give it a problem that only needs 1 step or a more complex one that needs 3 steps?
And finally, format.
This one is the most surprising. What happens if you just change the wording of the question slightly? Maybe you add a few useless words or rephrase the instructions in a way it hasn't seen before.
So what were the results? Did the Mirage hold up?
Not at all. It was even more brittle than they expected. When the test problems were identical to the training data, the models got a perfect score, 100%.
But as soon as they introduced a change,
It fell off a cliff. For the task test, if they gave the model a new combination of steps it knew, the model would often get the steps right, but the final answer wrong, just like the 1776 example. If they introduced a totally new task, it failed completely.
and for length and format,
Same story. Models trained on two-step problems couldn't solve one- or three-step problems. And even minor, meaningless changes to the prompt's format could cause the entire reasoning process to break down.
Wow. So the paper's conclusion is that this amazing human-like reasoning is really just a fragile illusion. The AI isn't thinking, it's just expertly replaying patterns it has memorized.
That's the takeaway. The authors call the AI's output fluent nonsense. It can generate chains of text that look plausible and logical, but are actually hollow and disconnected from any real understanding.
This has huge implications. If you're using an AI for something important, like medical diagnosis or financial analysis, you can't just trust its reasoning because it looks good. It might be confidently wrong.
Right, and the paper warns that simply trying to fix this by showing the AI a few new examples, a process called fine-tuning, is not a real solution. They call it a patch, not a panacea. All you're doing is slightly expanding the bubble of things the AI has seen before. You're not actually teaching it how to reason.
So the core problem remains. The AI still can't generalize to truly novel situations.
So is chain of thought reasoning a mirage? According to this paper, the answer is largely yes. It's an incredibly powerful tool for getting AIs to replicate complex patterns, but it's not genuine, flexible thought. It's a sobering reminder that while AI has come a long way, the path to true generalizable reasoning is still a long one.
a fascinating and slightly unsettling look behind the curtain of artificial intelligence. That's all the time we have for today.
Thanks for tuning in to Daily Papers.